Hey everyone, welcome back to the channel. In this video, we will discuss about recursions with C#. So far, in our previous videos, we have discussed about the user-defined functions. We have also talked about the built-in functions using the help of string as in reference type, and we have looked at different methods available with the string data type. Now, in this demonstration, we will talk about a different type of functions altogether with C#. Let's consider the scenario I would require to. Let's consider the scenario wherein I would require to calculate a square of a series of number. Let's say, give me the square of all the numbers starting from 1 to 10. So square of 1 is going to be 1, 2 of square of 2 is going to be 4, and then square of 10 is going to be 100, like this. What do we do? Simplest approach so far which we can answer is you would create a for loop, and then within the for loop you will take numbers starting from 1 and then until it reaches to the maximum limit, which is 10. You will multiply the number by itself and then you will calculate the square. That's absolutely fine, no issues with that. But as we are talking about the functions, what are you going to do? Are you going to make a call to a function 10 times from the for loop? That is another possibility. But if I tell you a quicker way without using a for loop, what would be your approach? Well, that's what we can achieve with the use of recursive function. That's one of the example which we'll be using in this demonstration. So let's say we have a function 1, we are going to call it as and I'm going to just now declare the function by providing the value, because I want the square of the number until 10. So right from the starting from 1 to 10, and I would like to have the square root, or maybe I can say that starting from 1. It's up to me. How do you want to define? I'll say generate method. It will generate a static method. That's intelligence you can use in C#. I'll remove this throw new not implemented exception because that's the default behavior. Now what I want to do here is this value, which is a value, I will instead of change from value v to value, will print the square root of this number val multiplied by val, and then what we'll do is we'll say if val is greater than 10, then return, because that's the limit we want to have it for our value function, our square root function. Okay, then what I can do is I can call to the same function, which is func1 in this case, and here what I'll do is I'll pass the value as in less plus, which is increment operator. I have to remove the func here. Here I'm making call to the same function. So first time the function execution starts from here, it will go here with the value 1, will print the square root of or square of 1 to 1 multiplied by 1. If checks 1 is greater than 10, no, it will go here. We are increasing 1 plus 1 is 2. We are passing the value 2 and calling the same function until it reaches to this condition, and we are keep on printing the method execution. Let's run this program and run. Here's the result. We got 1, 4, 9, 16, 25, 36, and so on. We have got a result for square of 11 as well, which we were not expecting. The reason for that is as soon as the value 11 comes here, by the time it has reached here, we were anyways printing it down. So what we could have done is we could have written the value here, and now if I run it, then we should be ignoring the possibility of getting the square of next increment number, which is beyond 10 basically. There you go. Now that is called the recursion, wherein your function is calling the function itself, right? Let's have a look at another example of recursion using the factorial number. So what we will do is we'll create another function factorial right? Factorial of a number. Let's say I would like to get a factorial of number 5. I'll create another method. That's my method to calculate the factorial. In this case, we'll say that the factorial of a number is let's say control v, print that, we'll call it as in value v multiplied by factorial, and then we'll pass it as a v minus 1. That's it, and that's going to make a call to this function itself. We'll return the function result. We'll get the result here and a result, and we are going to print the result. Now here in this case we have to decide the exit condition, and that's the main thing to remember about the recursive function. You have to have the exit condition for the recursive function. In our previous implementation we have exit condition. If number reaches to a limit beyond 10, then we are returning the function. So that's our exit condition. In this case, as we know that the factorial, as we are starting from the number for which we require to create a factorial, we are going to reach up to the value 1. If the number as reaches by decrementing by 1, if it reaches to 1, then we'll return 1. So that's our exit condition in this case. Let's see how does it works. As you can see that we have got the value 120, which is the factorial of number 5. Now how it is working, let me show you with an debug session here. So we have got the number 5, and as soon as we have got number 5, it's not meeting the condition. So 5 multiplied by 5 minus 1 and factorial of 5 minus 1, it is going to the same function, value is 4. Still it's going to the same function with a value 3 here in this case. Next it is going to the same function, this time value with 2. Next it is going to the same function with value 1, and as soon as I reach to the value 1, it goes inside the if condition. We are returning 1 itself. As you can see that as soon as we return with value 1, it goes to the exit condition. This time it's not executing this line because we have returned 1 from here, and as soon as it has executed this, it is going to the caller of the function, which in this case the caller of this value 1 was value 2. So it will go to this section where value was 2, and we are calling this. So 2 multiplied by 2 is 2. Again it will go to the caller of 2, which is with value 1. So we are going to multiply 2 with the result of this. 2 multiplied by 3 is going to be 6. Again it will go to the caller of value 4. So value 4 multiplied by 6 is going to be 24, and then it will go to the value 5. So value 5 multiplied by 24, and the result is going to be 120, and that is what we have received as in 120. So this is how the recursion works from the C# point of view. Now one thing to remember here is you need to have an exit condition for your function. If you do not have the exit condition, it is likely possible that you will get a stack overflow error. I'll show you an example of that. So let's take an example. I have a function which we are going to call as in func add, and I'm going to pass the value as in 1, and I'll create another method just for the demonstration. And what we are doing is we are going to print a value v here, which is what we have received, and we are going to call it a func add, same method, and this time we are going to add value 1 plus 1, or we can say that v like this. I'm going to increment that. Now as soon as I'm going to run this, what is going to happen is, as the value of 1 which is stored in the memory as in the stack of this value somewhere stored in the memory, we are keep on changing the value of parameter value of 1 in the memory location. It's just beginning with 1, then it has again changed with 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so on. As and when it keep on changing the value very frequently, it is possible that you will get an error of stack overflow because your all value types are going to be stored in the stack of memory. So let me show you and give you an example of stack overflow here. As you can see that it is keep on running the program, and it will run for a time, and then after a period you will get an exception which is stack overflow. So as you can see that I have started receiving the stack overflow exception here. This is what the exception it has written, and this is, there you go. So because here in this case I do not have the limit of my recursive function, how many times it wanted to run, and also even though if I have limit, let's say 10,000 times, then still I have a possibility to get a stack overflow because you are frequently overriding the value of that memory location, and the stack will overflow with the frequent changes and you will get an error. So that's one of the disadvantage with this with the recursive function, but in a way it is a smart way of writing the code and defining your logic to get the desired output, right? So do remember that first thing you need to have the exit condition, second thing that you need to make sure that how many times your recursion is going to run, because depending on that you may have the possibility to get the stack overflow error. And obviously as we are changing the memory location again and again, comparatively if you compare with the normal execution which is a for loop execution, it might possible you would get an error with it will run slow comparatively. So from the performance point of view also it would have an issue. But if you take an example of our factorial function, it is quite easy to get the factorial using the recursion flow, which I would not be able to get it very easily using the for loop, right? So there is an advantage of it. So it's not like everything is having a disadvantage here. I hope you have got some idea about the recursions with C# and you would be able to use it and debug it as well. Thanks for watching it. See you in the next video.